Page 54. The following figure shows a simply supported reinforced concrete beam with an internal span of 4,500 millimeters, supported to two 330 millimeter wide brick walls. The beam will support a uniformly distributed load of 28 kilonewton per meter. The overall depth is restricted to 500 millimeter. The beam is 220 millimeter wide. So we have an internal span of 4,500. We have a two brick walls which are 330 each, and then an overall depth of 500. So here is our data again. So let us start. Number one, we need to determine the effective span of the beam. Effective span of the beam. So we have an internal span which is equal to 4,500 millimeters. So when they say they want the effective span, again, effective span essentially is you told me in the middle of the brick wall. It needs to start in the middle of the brick wall. So 330 divided by 2, give me you know, this side 165, this side 165. Again, we're dividing our wall into 2. We are saying the effective span that they want there should start in the middle of the wall until the middle of the other wall again. And we have an internal span which is 4,500. You know, since we have 330 and 330, we need to divide this 330 into 2. And then since the effective span needs to start here, you know, to 165 plus 4,500 plus 165. Like 165 plus 4,500 plus 165. Effective span, this span somewhere is determined in the middle of the walls, again to the other middle of the wall. So we have internal span of 4,500. We need to say 4,500 plus 2 of 165. I gave you 165 this side, 165 this side again. So it's 2 of 165. What do we get?
4,830.
4,830. And then also write it in meters, 4,83 meters. Like how to get the effective span? Effective span determined in the middle of the walls. Okay, so now we determine the effective depth. So how do we determine the effective depth? We have an overall depth of 500. Again, they told us on the statement that our overall depth is 500. Here is the overall depth, it is 500. So we're going to say 500. Would that be if we had an overall depth and then let's say our cover is 50, our overall depth is 500, and then we want the effective depth. Let's put it as overall depth minus cover again, and then we get the effective depth. So now we have an overall depth of 500. Mara, did they give us a cover? They did not give us a cover again. So we can assume our cover as normal. Give our cover. 43, what a random number.
What's a good one? Oh, because I'm shit. I think we more than 25%.
It's only 5 to 10, 43. Why not 40? Not 43.
No, you know the word really rates.
Hey, Aziman covered, Aziman 50. So it's 500, which is the overall depth. Overall depth minus the curve. Formula to get the effective depth, if you have the overall depth, is overall depth minus curve again. So we assumed 50. So shall I say 450 millimeters. So this is our effective depth. Okay. Now let us calculate the loading. The loading of the beam. So loading of the beam, we need to calculate the dead load first. Dead load. Formula calculate the dead load here. What's the formula to calculate the dead load? Volume times density times GA times 1,2 GA. So what is our volume? Volume here rectangular beam, we said it's L times B times height, and we said the length is over all them. Length is over all them. B is the breadth or width, and then height is always 1. That's what I said. So what is the length? What is the overall depth? 500. You write it in meters. So it's 0,
0,5.
0,5 times what is our breadth?
0,
0,33 again. No, what like the beam is 220 wide. Even more.
Oh yeah.
The beam is 220 wide. Width, we don't take the width of the walls. They want the width of the beam again. So beam here is 220 wide. So it's 0,22 multiplied by 1. What is our density? 2420 kilograms
kg per meter cubic.
And then GA
9.81 times 10 to the power minus 3
times 1,2 GA again.
Yes.
So let us find the answer.
So then we calculate
3,133 kilonewton per meter again. So now let us go to our statement. They gave us a UDL, like what the beam will support a uniformly distributed load of 28 kilonewton, like what? So how do we calculate a UDL?
times 1.6 QA.
So it is, they gave us 28 again. So it's 28 kilonewton per meter multiplied by 1,6 QA. What do we get? What is the SI unit for UDL? Kilonewton per minute. So after calculating the loading of the beam, what do we calculate? Bending moment maximum again. So the bending moment maximum is equal to WL squared over A. Why WL squared over A? Keep that load here again. And then UDL or negative WL squared over A. If there was a point load, no over WL over 4. So it's plus WL squared over 8. So what is our W? This one is for the dead load. This one is for the UDL. W for the dead load, you can
3,133.
3,133. And then L, what is the L?
It's squared.
L is squared. So L is equal to squared. What is our squared?
4.5.
4.50 squared divided by 8. Plus W for the UDL?
44.8.
44.8 times 4.50 squared divided by 8.
Why the spending is 4.5? Internal spend.
Yes, one.
I'm going to calculate the
Hey.
effective spend now.
Over internal spend, we calculated the effective spend. MEA, no, we're trying the effective spend, not internal, effective spend. So what is our effective spend?
4,83.
For